Okay, in this video, we are going to discuss how to find the midpoint of a line segment. A line segment is a portion of a line. So we discussed in math that a line goes in the same direction and has infinite length. A line segment does not have infinite length. So the line segment PQ only extends between the points P and Q. And what we're going to try to do in this video is find the coordinates of a point M. M stands for midpoint. And what we want to do is we want to make sure that point M is going to exactly split the line segment PQ. So the point M is going to split the line segment into two equal parts, the first part PM and the second part MQ. So we can always, for any line segment, find a midpoint that splits the line exactly in half. We call this bisecting the line segment. And the way we can think about this, well, first, why don't we write down the coordinate of the point? So P is at 1, 3, and I think Q is at 7, 9. So first the x coordinate and then the y coordinate. And our goal here is to find the coordinates of point M. Now when I've drawn M on this graph paper, it looks like it's right, but I've just guessed or estimated. So in this unit, we're trying to find points or characteristics of geometry analytically or algebraically. So we're going to try to find a technique that allows us to exactly be sure that we found this point that bisects line segment PQ. Well, we can think about again any 2 points as being separated by their rise and their run. So the rise would be the vertical distance, or the y coordinates of P and Q. Now point M is going to be exactly in between there. So my new y coordinate is going to be exactly halfway in between 3 and 9. And same thing, the run between points P and Q is that horizontal distance, or that change in x. So my new x coordinate is going to be halfway in between the old x coordinates. It's going to be halfway in between points 1 and 7. I could count that out to find half the distance. So halfway between 1 and 7, well, that would be 4, because 4 is 3 bigger than 1, but 3 smaller than 7. And same thing, to find out my y coordinate, I could think of, well, what's halfway between 3 and 9? Well, 6 is halfway in between. It's 3 bigger than 3 and 3 smaller than 9. So I could count or reason out what's halfway in between. What we want to do is have a formula that's going to work for negative numbers, decimals, large numbers, or if we don't have graph paper. So I'm going to develop a formula for the midpoint of PQ. And again, this subscript or label beneath the M says this is the midpoint for line segment PQ. What I'm going to do is I'm going to develop a formula to figure out what's the halfway point between P and Q. Well, the first thing I want to do is my x coordinate has to be halfway between the two x's. So I want to average the two x's. So what I'm going to do is I'm going to add up both the x coordinates, and then to find out what the average is I'm just going to divide them by 2. So I'm going to do xp plus xq divided by 2. Same way that to find your average in high school, you would add up your marks for all 4 courses and then divide by 4 to figure out what's that middle point, or what's your average mark. So same thing, the midpoint or the average x coordinate, I add up the two x's and divide by 2. And then to find my y coordinates, I'm going to do the same thing. I'm going to add up my two y coordinates and divide by 2. So I'm taking the average of the x's and the average of the y's. And that's all I need to do. So the x coordinate of point P was 1. The x coordinate of point Q was 7. And then I'm going to add those together and divide by 2. So it's almost like I have 2 separate formulas. One formula to find my midpoint x coordinate, and a separate formula to find the midpoint y coordinate. So the first y coordinate for point P is 3. The second y coordinate for point Q is 9. And I'm going to add those up and divide by 2. Again, when you're doing this or evaluating this in your calculator, make sure you simplify the numerator to one number before dividing. So I want to know 1 plus 7 is 8. And then on my last step, I can divide that by 2. Same thing, 3 plus 9 is 12, and then divided by 2. So my midpoint, which we'd already found just by counting or by inspection on the graph, is going to be 4, 6. So 4, 6 is the point that bisects line segment PQ into exactly 2 equal portions. And what's nice is this formula, or this idea of averaging your x's and averaging your y's, is going to work no matter what the initial points are. So let's look at one without graph paper. Maybe we have some decimals or some negatives. So let's look at point A. I don't know, we'll call negative 3.5 and 0. And I can say point P is positive 2.5, and let's say negative 7. I'll make sure that's visible on my camera. I know my camera's a little bit laggy today. So again, we're going to use that same formula to find the midpoint. We're using capital M for midpoint. Lowercase m would still mean slope. If I want to find the midpoint of this line segment AB without graphing, I'm going to take my two coordinates, xa plus xb, and I'm going to average them by dividing by 2. And then I'm going to separately calculate halfway between the y's, halfway of my run, by doing ya plus yb. The order doesn't matter when we're adding, so I could do yb plus ya divided by 2. I've got one formula with x's to figure out my new x coordinate. I've got one formula with y's to figure out my new y coordinate. So I've got negative 3.5 plus 2.5. So I'm going to add those up first and then divide by 2. And then my y coordinates, I have 0 plus negative 7. Again, I'm always adding them up and then dividing by 2 to calculate my average or my middle. I'm dividing by 2 because I'm averaging just 2 points, the start point and the end point. So I've got negative 1 over 2. That's already a reduced fraction. And then 0 plus negative 7 is the same as 0 take away 7, negative 7 over 2. So now I've calculated the midpoint of A and B. And I have my answers in fractional form. I can't reduce here, so that's simplified without having to graph it or to count anything, which can get tricky when we have decimals or when we have large numbers. So that's how we can use the midpoint formula. Every line segment is going to have a midpoint. It splits into 2 sections. And again, if we wanted to, I could confirm that result using Desmos. Desmos is a great way to check our answers. I would always, when I'm trying to find the midpoint, what you might want to do is have a rough sketch just to see, well, does that answer look reasonable? Does what I've found look like it's halfway in between? So there was point A given in the question. And then point B was also given in the question. So there was A and B. And what we did algebraically is we found this third point M, which was negative 1/2 and negative 7 over 2. And sure enough, that looks like it's going to exactly split that line segment. So I think it's always nice to have kind of a rough sketch or graph to check your answers. The graph isn't enough to determine an answer, especially if they're decimals or negatives or large numbers. But checking the graph can answer the question, well, is that reasonable? First of all, does the midpoint look like it's on the line segment? Yes. And does it look like it splits into 2 equal parts? Well, it does. So we're probably on the right track. So that's it for midpoint. Send me an email or comment on this video if you have any questions.